Today I'm going to talk about a very special class in Java, which is string. And as you know, string in Java is the class that you use to create instances of text values. So what exactly is a string in Java? A string is an object which is backed by a char array. So basically, it's a class. So if you open the Java source code and inspect the classes under java.lang package, you would see that there is a string.java class. And in that class, you will see that there is a char array defined, which finally holds the text value that you want to represent using that string. So now, string is one of the most widely used classes in Java. And it's used in a lot of different places in different ways. And then I don't think there exists any application in the world that is written in Java that does not use string. So being a very special class, there are so many special characteristics assigned to them. So, and thus, due to all the characteristics and features, strings is one of the most popular interview topics for core Java. So now let's dive into further details of strings. So string class is immutable and final. So a class being immutable means that once it is instantiated, its state cannot be changed. And when you're talking about string, the content of that string cannot be changed. So and final means you cannot extend that class, string class, and override its behavior and kind of end up breaking the invariant of the string class. So let's try to understand what exactly is the string immutability. So let's consider an example of strings. So let's see string s1 is equal to hello. Now, in Java, generally when you do s1.to uppercase, you would expect that s1 would be converted all to uppercase now. So now let's try to print string s1 and see what happened to s1. So if you run this example, you'll see that it's still the same old value. So calling an API to uppercase did not really change the value hello into its uppercase equivalent. So by design, string is immutable. So what if you want to get the uppercase value of s1? So by design, the toUpperCase method returns a new string, and you have to handle that new string in a different variable to get the uppercase string. So now you can say that string s1, the value hello is immutable. So that quickly shows you that the string is immutable. And we'll go further and discuss why the string is an immutable class. So before that, we need to understand a couple of topics like string code. So as I said, Java is a very special, Java string is a very special class. So in Java, strings are stored in a very separate memory area called string code in the permanent generation. Which is basically the method area of the JVM. So that means is that each string you create is cached. So in the previous example, the moment I created the string hello, it is cached in the string code. Now if I create another variable s2, which is also hello, what will happen is JVM will go and check the string pool to see, do I already have a string that looks exactly like hello? So if it finds that hello in the string pool, it'll return its reference to s2. So now s2 will also point to the same string object in the string pool. So That means if I check the identity between S1 and S2, they should be equal. So how do we check that? Using the double equals operator. So S out are the same reference. S1 double equals S2. Now let's see what happens when we run this application. Are the same reference? True. So since S1 and S2 are pointing to the same hello string turned into the string pool, we are pointing to the same reference. Now, there is another way in Java to create a string, which is string f3 equals new string of hello. So this is another way of creating a string in Java. So when you create a string using this double quote approach, that's called using a string literal. When you're doing this, you are creating a string using a new constructor. So when you do this, this string is not interned, or JVM does not search its string pool for this hello and assign that reference to S3. So that means S3 is pointing to a totally different new object in the heap. So let's see that example. So now if I check the identity S out, system out, println, S1 double equals S3. So now let's see if S1 and S3, if they are all the same object reference, which it is not. So when you run this program, you can see that they are not, their identity does not match. So S1 double equal to S3 fails. So that means the hello string is not interned. So how do we make sure that JVM searches a particular string in the string pool before it assigns the reference? So how do you do that is by invoking the intern API aunt. So if you call the intern, now it is interned. So now if you check the identity S1 double equals S3, it should return true. So let's see that. It's returning true. So with this example, you can see how JVM looks up the string pool and returns the reference if the string is already existing in its string pool cache. So this whole process is called interning the string intern. So the intern operation is actually since Java 1.7. The string cache or the string pool is not stored in the permgen. Instead, it's stored in the main heap area. So up until Java 1.7, string pools are maintained in the permgen, and since Java 1.7, it's maintained the main heap. Now, what is the need of creating a string pool? It's very straightforward. It's basically caching of strings. So strings being the most widely used objects or class, it makes sense to cache them so as to optimize memory. For example, let's just take a very random example. Suppose we have a batch file processing application which runs for a fairly long time. And suppose input to this batch processing application is a file with 100,000 records with names, etc. on it. Okay. Suppose this 100,000 records, 50% of them contains a common name. Like for example, Kumar is a very common name in India. So suppose 50% of the 100,000 records contain the common name Kumar in it. So so that means we have 50,000 strings Kumar to deal with. Suppose the application goes and creates new object for Kumar every time it encounters Kumar in the record. We would end up with so many objects, say 50,000 objects in the memory for every time it encounters that string. So to avoid this and optimize memory usage, what JVM implementers, Java JDK implementers have done is that the moment they encounter a string literal, it's cached in the pool, and next time the same string literal comes, the reference of the existing cached instance is used. So that's how the instance pooling or interning helps in optimizing memory. So let's get back and see why string is immutable. Given this, we now know about the string pool or interning. So given that, let's inspect why the string has to be immutable. So with the concept of string pool or caching in place, suppose I have a string s1 pointing to hello, and now I have another string s2 pointing to hello. Suppose I call s1 to uppercase, and let's assume for a second that if strings were mutable and calling to uppercase actually modified this string, that will indirectly impact s2, which is not at all expecting its string to be updated. So that means, to preserve the instance that is cached, we cannot let a string to be mutable. So making that will cause unexpected results in the other string references which are pointing to the same instance in the instance pool. Now, that is the main reason. And being immutable, you can pass around a string without worrying its state to be impacted by various threads. So it's thread safe by making it immutable. And also, by making immutable, strings caches their hash code internally. So the moment you create a string with certain literal, its hash code is computed based on the characters and cached forever. So that means every time you have to invoke the hash code value for, say, hash-based data structure, like to be used in hash maps, we don't have to every time go and compute hash codes. And this is really useful when you're dealing with large strings with a lot of characters. You don't have to compute hash code going over the whole string. So that is one of the benefits of making it immutable. So these kind of summarize why a string is immutable. And according to me, the main reason is to support the behavior of string caching in the string pool. Now, by the way, and talking about hash codes, and strings happen to be one of the most popular keys in HashMap. So definitely caching the hash code gives you kind of a performance boost in that aspect. Now let's inspect a few of the string APIs. So if you have worked in Java for about, say, a couple of years, you would have come across most of the string APIs by now. So I don't think I have to explain them in full detail, but I would just like to highlight certain really useful string APIs here. So for example, if you want to check if a substring is part of the actual string, you could use the index of operation. So it will give the index where the substring actually starts in the parent string. For example, suppose I want to check where you have on s2.index of, I want to see where is LO. So that means, when I run this program, I get 3 as the output. So what that means is that the index starts with 0 as always, 0, 1, 2, and 3. So this is the 3 is the index where the substring LO starts in the string s2. So similarly, you can compute suppose you have a lot of LO in the string, and you want to know the last index of LO. So you could use the last index API as well. So that is the last index. Then there is the contains API, which returns a Boolean to if a given string contains a certain substring. And in Java, there is the string API has been enhanced with the regular expressions, and that when the string operations has become more powerful. So, for example, there is this matches API which takes a regular expression and checks there is a match. And when you come into the realm of regular expressions, you get immense power of processing text. And since regular expression itself is a very complex topic, not exactly complex, it's a very wide topic. I'm not going to cover regular expressions here, but using regular expression APIs gives you a lot of power in terms of searching and checking matches and counting matches, etc. So let's take a quick example of the matches API. Suppose I have a hello world here in S1, and I'm going to see S1.matches anything followed by word. So I don't care what precedes the word. So I want to see if it matches this particular regular expression pattern. So let's run this little program and see what it prints. True. So it says anything followed by word, yes, S1 matches it. So similarly, there are a bunch of regular expressions that you can use in order to check patterns in your input strings. Now, talking about regular expressions, I would like to talk about sometimes in interviews you would be asked to count matches of a specific substring in a string. So there are a bunch of ways. Sometimes you would have to implement it by hand, where you have to call index of and count the occurrences. Actually, you can use the regular expression API that is available in Java in order to count the occurrences. Suppose I want to count the occurrences of word hello in this string. I'm going to use the regular expression API. So let's see pattern equals pattern dot compile hello. So I'm going to compile a regular expression pattern here. Now I'm going to get a matcher from this pattern for the given string S1. Now, while matcher.find, I'm going to increment occurrences ++. So now let's check. So what happens is that I'm going to use the matcher, and whenever matcher finds the pattern hello in the string S1, I'm going to increase the occurrences, and finally I'm printing the occurrences. So in this case, I should get 1, 2, and 3 as the answer. So let's go ahead and execute this little application and see 3. So this is one of the ways to find matches of a specific substring in a string. And there are a lot of different ways you can do this. I just wanted to show how you can achieve this using regular expression as well. Now let's go and talk about substring. A substring actually returns a piece of a string from the given parent string. So let's use the same example here and try to substring. So suppose I want to substring the string from here until here. So I'm going to say the begin index and the end index. So what I'm going to do is that 0, 1, 2, 3, 4, 5. So I'm going to say system out s1.substring begin index, which is 5 in my case, because it's here 0, 1, 2, 3, 4, and 5. From here, I want till say D. Okay, so that is index 1, 2, 3, 4, 5, 6, 7, 8. 5 and 8. So now, if I run this program, you'll see it has substring as I wanted. Now, this is very fairly straightforward implementation of substring. But substring operation happens to be a favorite topic of interviewers because there are some hidden gotchas or interesting aspects in the substring of Java. See, for example, suppose I mention a big index which is not there in the string. So what would happen is that because this index is out of bounds because it's not, the length is not 50, right? So if I mention like a higher index, it's going to throw a string array index out of bounds exception. So let's run, and as I said, it has thrown that exception. Okay, fine. So let's see what happens if I say length. So again, we might expect that if you do this, it's going to throw the same exception because it's working on index, begin index. But you should notice that if you look at the Java String API, it clearly says that you can you can mention including the string length as the parameter for substring. So when I run this does not really throw the array index out of bounds exception. Instead, it returns me an empty string. So let's see that by running this example. You see this? It has returned me an empty string. So that is the one of the peculiar behavior of substring operation. And now there is a very interesting aspect of substring operation that we should know, which we'll take a look real quick here. So up until Java 1.7, the substring operation was a source of memory leak. And why it is a source of memory leak was because when you start substring the original string S1, Java used to create a new string, but that new string would eventually contain the same character array that actually S1 had. So that means, suppose I create a new string S2 by substringing the string 1 from index 1 to string index 5, and I print the result S2. So let's see what I get. ELLO. So here I would expect S2 to have a char array within it, which has only 4 elements. But that's not the case in up until Java 1.7. So let's take a look at this by debugging this example. And here in my example, I'm using JDK 1.6 to demonstrate this. So I'm going to run and check S2 once it is created. So let's run debug this example. And while it is debugging, yes, I have S1, which is a very big string, and S2 is the small substring of it. Now, if I go ahead and inspect S2, I have this char array in the S2, which actually refers to the original long string. You see that? Everything that was part of the parent string is still there in the substring. So that means there is obviously a memory leak because this S2 value is referring to the value that is in S1, and especially suppose I don't need the S1 now, I just need the smaller string. But since I'm still referring to the large value array, the value array will not be garbage collected, and that will be a source of a memory leak in strings. So this issue is fixed in Java 1.7. So let's take a quick look on why this is happening in in versions up to JDK 1.6. So I'm going to go into the substring method and take a look at how it works. So there is substring is calling this substring, and eventually it's creating a new string using this constructor. Okay, so if you inspect this constructor, see we are sending this dot value. This dot value is the whole char array of the source string. So now I'm creating a new string with the offset and the number of characters I want to choose and the whole character array. But this constructor, if you inspect, is actually assigning a new, the new strings character array to the whatever character array is passed to it. It's not really storing the little part of it. So that is the source of this memory leak. And since JDK 1.7, this has been fixed using a separate different string constructor, which actually copies only the part of the char array passed to the constructor based on the offset and the count. So that's how this memory leak is fixed in Java 1.7. So just note that the substring had a memory leak up until JDK 7.0. Now let's touch upon real quick on one of the favorite topics of interviewers, which is the string buffer, string builder, and string. So what are string buffer and string builders? So string buffer and string builder are data structures which are very similar to strings, but which are mutable. So when the Java implementers made a string immutable due to various reasons, such as the caching as well as the various places where it is used and to make it thread safe, etc. They have also provided classes that are mutable, which represents strings. So string buffer and string builder are basically mutable data structures which are similar to strings. And string buffer is somewhat legacy, which is a synchronized implementation. That means every method in the string buffer has a synchronized keyword on its public API, and string builder is not synchronized. So string buffer, you can say string buffer is a thread safe implementation, and string builder is not a thread safe implementation. So most of the cases you would use string builder. Now let's go ahead and look at some operations like the plus operator versus string builder.append versus concat. So in Java, previously in Java actually we are discouraged to use the notation plus, which is an overload operator for string, which lets you append a string at the end of the other string. Actually, it can be anything. So I can create a string like string s equals this 20 plus is this 20 is boolean value of string. So see, using plus operator, I can create append various different kinds of data types to the string, and if I print the string, I'm going to get a string which is a composite of all these strings. So let's take a look. So basically how it works is that these are converted to string representation internally, and a string is totally created from here. So this approach was discouraged previously because this would actually give rise to a lot of intermediate strings, especially if you do this in a loop. You don't know how many strings you are adding to each other. So what would happen is it would give rise to a lot of intermediate strings, and which is supposed to be a lesser efficient in terms of memory and execution. So this was discouraged in Java. So now let's take a look at how this gets implemented in modern VMs. So once I do this, let's go to the command line and C the bytecode Java P minus C example1.class. So when I do this, see this nowadays in JVM, the plus operation gets implemented using the string builder. So it's a string builder.append, and string builder.append. There is no intermediate strings created for this purpose. It's all done using the string builder.append, and at the end, the toString is returned to store the string value. So that is the plus operator and string builder.append. So this plus operator here is as good as saying new string builder of this dot append 20 dot append true. So the now this and this essentially becomes same type of operation in terms of how it is constructed. Now let's look at the concat operation. So string also gives you a concat operation. So let's say string s1 equals ab, and string s2 equal to cd. Okay, my code formatting is looking a bit horrible here. So let's format this a little bit. Okay, now let's use the concat operation, which is s1.concat s2. So if I run this, the strings are concatenated. Now the difference between this and the plus operator or the string builder.append or the stringbuffer.append is that S1 the concat operation works only with the string type. You cannot just concat an int here. Okay, see, that's a compilation error. So that is the main difference. And S1 this concat operation is kind of efficient when you're dealing with a small set of strings, like 2 strings you want to concat. You can use the concat operation. But when you're dealing with a large amount of strings, it's always good to deal with deal with the string builder APIs. Now let's move on to a little bit of a word on best practice when you're using string. This is kind of very fairly obvious that you would probably already using, but I would like to touch upon this here. Suppose we have something like string s is coming as a result of some operation, okay, and you have, suppose, static final constant, static final string success equals success. Now I want to check if the result of this operation was success. So if I can do if s dot equals success, system out println operation was successful. Else, you want to do something else, up to you. So here is the example. So I need to implement this some operation. Let me just create a method here. So suppose, unfortunately, my some operation is going to return null due to whatever reasons. Okay. So now let's see what happens in this code. I have a null pointer to deal with now. So because of the way I have used this if condition, I'm ending up with a null pointer, because this operation returned me a null, which I was not expecting. And naturally I was coding like s equals success. I want to do something, but since s became null, I have a null pointer at that line. So to avoid this, what generally has to be done is you have to just inverse this comparison. You have to say success equals s. Okay, so this actually is better than saying if s not equal to null and s equals. Okay, so you could actually do it by using the not equal to null check, which again is a very verbose way of writing code, which I think is not a best practice. So you could just invert that comparison, and you can say success equals s, because success is always something initialized; it's never null. So you can confidently go and say success dot equals s. It doesn't matter if it's null or not. You at least you won't get a null pointer. So you can proceed with your application. So now let's go ahead and run this example. And you see that you don't have a null pointer. The null pointer exception is gone. Now, let's just add an operation fail. Now you get the operation fail because this went fine even though s is null. We went to this else block and printed our message. And the moment we return a valid string out of this, everything else works fine. To conclude this example. So that is a quick word on the best practice when using string in scenarios like that, when you're comparing to avoid unexpected null pointer exceptions, especially when you're dealing with a return value from some API which you did not write and you don't have any documentation which says if it's going to return a null or an empty object or whatever the case may be. So now let's go to one more topic on string, which is about storing passwords. So string in Java, string is not a best way to store passwords in your production applications. Instead, you should use a char array to store your passwords. The reason being, strings are created in the string pool and they are maintained for a certain period because they are cached and they are cached for a certain period. They don't get garbage collected real quickly. Okay, so what that means, once you suppose by accident your password is clear text and you stored that in a string variable and you put that in your constant pool, string pool, and if somebody gets a dump of that memory, he can clearly go and read the password that are out there in plain text, which is definitely a security threat. So instead, you could use a char array and store the password in the char array. And as soon as you're done, dealing with the password, you can just set the char array back to null, or set all the elements in the char array to zeros, etc., so that the actual value, gets garbage collected, and that threat is mitigated. That is one way of this. Actually, I touched upon this topic because that is one of the I've heard this being asked in certain interviews about what is the best way to store passwords in Java, and the best way to store password is using char array. And again, there are a lot of other better ways like hashing and using salts, which are all a different topic, a different story for a different time. So today, I think I'm going to conclude my video about strings, and just keep in mind that strings are very special in Java, and they have all these very special characteristics such as immutability and in certain APIs which are kind of tricky, like the substring, which lets you substring on the length of the string as well without throwing an exception, or which was source of a memory leak up until JDK 7.0. And also one more point that I want to emphasize back is that the string pool up until recently, it was stored in the permgen, and now it has been moved to the main heap area of the JVM. And that pretty much concludes the video about string. Thank you.